Good morning, good evening.
Hi, Karthik.
Hi, Karthik. Good evening.
Hi Nitya, hi Shravani. Thanks for joining. All right, I think hope you guys are doing good. Now we can start today's class. Actually, this was planned yesterday, but some reason like we couldn't make it yesterday. So I would say this one we are targeting for today, which is March 22nd, right? So basically, we are going to start with only one um, subject today, which is to understand how hash map internally works. This is one of the most uh, I can say frequently asked or for sure asked question in interview if you go for Java developer to understand how this works so that you guys will be able to handle the collections effectively. So it's very, very important to understand this concept. Once you know hash map, this hash set and hash table we can see tomorrow. And then this one we can do it on Thursday so that we can complete this one by this week. So that's a plan for this week. So let's get started. So today we are going to start with how hash map works internally. Being said that, so today's agenda is we are going to look at how hash map internally works. In this, we are going to learn about what is hashing concept, what is rehashing, what is collision, and how hash map internally uses hash code method to store the objects, and how hash map uses equals method to retrieve the objects internally, and what is the change made in Java 8 with respect to hash map, and why Oracle team made the change. We are going to see in and out of it. All right, let's get started. So if you guys see the screen where we are having kind of a diagrammatic representation where I mentioned like how the hash map internally works, right? So whenever we say hash map HM is equal to new hash map of, right? So what does it mean? It actually creates an object of this hash map class by using the new keyword, and using this constructor it is going to construct it. So what it is going to construct? It's kind of like array of buckets, okay, to store the data. Whenever I say the default capacity is 16, which means it is going to create with table of 0 to 15, okay, where it is going to store the data, whatever we are going to add it. And the default fill ratio is 0.75, which means once it reaches 75% of the data, it is going to make a copy of it, and then it will extend it, and then it will go into store it. So we'll see how it actually internally works. So before we start with that, let me start asking you something like, we know hash map is a class in Java, right? When we need to go to hash map, can you guys tell me when we should go to choose hash map? We know the hierarchy. Map is interface in Java. We have map interface, which is nothing but whenever you want to store key value pair, you have to go for map interface. And within this, if you want to store the data where you don't need to maintain the insertion order, then you can go for hash map, because hash map means using the hash code of the key, it is going to store the data. We have seen in our previous classes, right? Now we are going to see how it internally works. Okay, that is agenda for today. So whenever I say hash map HM is equal to new hash map of, what it do is, let's say if you say hash map let's say HM is equal to new hash map of. Okay, stop me guys if you guys want to reiterate some of the concept, but it's very, very important to understand. So what typically happens in this line of execution, it is going to create an array of buckets, okay, with capacity as 16 and 0.75 is the fill ratio, which is a default constructor, right? So which is nothing but 16 means 0 to 15. Okay, so this buckets are ready. Now it has to store the data. So when it will store the data, whenever we say hm dot, in hash map we have a method called put of key comma value. right? So let's say you are adding some value. Let's say Red9SysTech. This is the key, and the value. Let's say you are saying for Java. Okay. So ideally, it has to store this key and value, right? Only then, whenever you are going to retrieve the data by giving the key, you will get the correct value. So how it internally stores, that's what we are going to see it now. So we know this is the key, this is the value, right? So this is the key, this is the value. Okay. So first what it will do is, since we create hash map of, since we create a hash map of the constructor, so if you go to the internal implementation of this put method, okay, what they will do here is, first they will apply the hash code key dot hash code of, which means they're going to apply key dot hash code of. So what does it mean? They're going to apply hash code method on this particular object. Here, what is this object? String object, right? Because Red9SysTech is a double quotes string object. So in Java, we know for every class or object, there is a class called object, right? This is a superhero, right? Super or base class for everything in Java, or I can say every class in Java. The base class is, or the super class is object class. Whether you inherit or you are not extended, by default it is the base class. So in one of the class we have learned about, there are multiple methods inside this object class, right? Let's say toString and hash code method, right? And also we have seen about equals method. Lot of methods we have seen, right? So what they're going to do here is, on the string object they're going to apply this hash code method. Okay, based on this hash code method, it is going to return some value. Using that value, using this particular whatever the hash code output, I can say output of the hash code, they will do a logic, because here we have the size is 0 to 15, which is nothing but 16, right? So they will apply operation here on this output value with this 16, and then they will finally get index or bucket number. I can say bucket number. Okay. So using this one, this key will be stored here. Let's say if this bucket value we are getting as 0, assume that, okay, then this particular key will be stored, this key value pair will be stored here, the 0th location. But how it will be stored is as a linked list. What do you mean by linked list? What do you mean by linked list? This is null, this is null. Basically, this is key. Basically, this is a key. Here to store the value. Here, this is the hash code. So in this case, here it is going to store Red9SysTech in this, and hash code will be whatever it is getting. Let's say this hash code is, let's say 123. Okay, so this will store 123 here, and this value is nothing but for Java, and this is the reference for. Right now it will be null because it don't have any other list, right? You guys know about linked list. We have seen how the linked list will be connected, double linked list or linked list, right? You'll have address reference for next one. So right now this is null, so it won't have the second one. But for some reason, let's say you're adding one more one. Let's say hm.put of null, comma AWS. So for the null, you will get the hash code is 0, and let's say you're getting again same bucket 0. Then what happens? It has to store the same. It has to use the same bucket to store the second value, which is nothing but null, comma AWS. So in this key, here to store the key as null, and hash code, let's say 0, and value is nothing but AWS. and this will be null, isn't it? Because it's address reference for next linked list. Now this null will be replaced with whatever the address of this particular list. It's like a memory reference. Only then it can go from here to here, navigate. Right? So this is how it internally works. I'm going to give a proof of concept, but before I go into that, I want to give you guys a diagrammatic representation of how it works internally. So are you guys clear, both Shravani and Nitya? Can I go and start writing a code and then I will show you how it actually stores? Can you guys hear me? Hello? Hello? Shravani, you there? Hello? Are you guys there or not? Yeah, Nitya, I think you are dropped off and now you are back. Can you hear me, Nitya?
Yeah, yes, Karthik.
Okay. This is understandable, right? Nitya, can I go and write the program?
Yeah, yes.
Okay. I can't hear anything from anyone, so thinking whether. Okay, let me start writing the class. So this is nothing but hash map internally works demo. Okay. So here what I'm trying to do here is hash map hm is equal to new hash map of. Okay. Now, if you guys go to the hash map class, you guys will see all the implementation, right? Where it is using, how it is using. So it implements map interface, clonable, serializable, everything, right? And if you guys see here, the put method, the default capacity is 16. You'll see 0.75 is 0.75 is the loading factor or field ratio. Minimum maximum capacity is 16, right? So what I'm trying to do here is I want to show you example of what we are having here. So channel name comma register. That's what I'm going to add it. So hm dot put off. I'm going to have put method. In this one, I'm going to store one key and one value, right? So the key value pair which I'm going to store is like whatever I have it in this slide, 1, 2, 3, 4 values, right? So 4 values I'm going to store it here. Okay. So 4 values means 4 key value pair I'm going to store it. Okay. 2, 3, 4, right? So the first one I'm going to store as channel name. Okay. Channel name, and the value is Red9SysTech. And second one, course name Java. Okay. Course name I'm going to store it as Java. And the next one is course ID 0001. Let's say course ID 0001, and then null comma 0001. Okay, so null, it shouldn't be a, this should be a null comma 0001. So Now I'm going to simply print it, right? HM. Now I'm going to run this program in the debug mode so that you guys will understand how it internally works. So run debug, switch to the debug mode. Okay. Now my breakpoint is here. I'm going to execute first statement. If you guys see here, the line number 6 has been executed. Now the hash map has been created here with nothing is inside, right? You guys see here, nothing is inside, right? Now I'm going to add the elements. Let's say line number 7 got executed, right? Which means channel name comma register has been added, right? So channel name is equal to register has been added. And if you see, it is added under the hash code of 0. Okay. And similarly, if you go to the next one, okay, course name comma Java, this has been added. And if you go to the next line, course ID comma 000 has been added. Course ID equal to 0001. This has been added. You guys can see the value here, how it is going to add it, the nodes and other stuff. Course ID 0001. And then I'm going to add null comma 0001. If you guys see here, null 0001 has been added. Okay, you guys can see it here. And if this is not clear, visible of understanding this one, maybe you guys can see here. Okay, the same code I have executed in my Eclipse in previously. So where you guys can see hash map has been created. Underneath you can see the table has been created with 0 to 15, which is nothing but these are the buckets. So in each bucket, whenever you execute line by line, it is keep on adding. If you guys see here, the bucket number 0, where you guys see here, these two course ID null has been added under bucket number 0 because hash code of null is 0 and index is 0, right? So on the index 0, you guys can see key is nothing but course ID and the value is nothing but 0001, right? Which is nothing but course ID 0001. And also on the same bucket 0th index, you have one more key value pair, which is nothing but null 0001. There's nothing but here. If you see next is null, right? And this value is 0001. So this is how it internally uses. So now if you guys see, what do you mean by hashing concept? So hashing concept is nothing but the way how it internally uses hash code method in order to identify the bucket. It is using hash code method on the key, right? So this mechanism they call it as hashing. Hashing is nothing but the process of applying hash code method on the particular key in a hash map. What do you mean by rehashing? As I said earlier, the default value is 0.75, right? So once it reaches 0.75, then it is going to create a copy. It is going to make a clone of this one into another hash map with more space or more buckets, right? So that time, whatever you have it here, it will be automatically copied everything, right? So at the time, it will use the same hash code method to identify the right buckets. So when it is going to do it second time, because of just it's going to copy the hash map, that process they call it as rehashing. Okay, what is collision? So collision means on the same bucket, if you want to store more than one key value pair, that behavior they call it as collision, because if you get the same hash code or if you get the same bucket, right, which means like you have to store both the key value pair in the same bucket, because internally it is using linked list. So you will be able to see it, right? So it will be stored here. So this process of having more than one key value pair in the same bucket internally within the hash map, that process is called collision. And how hash map internally uses hash code method, how internally uses equals method to retrieve. So what happens here is, if you guys see here, the internal implementation of put method, when we use put method, it internally uses key comma value, right? I will show you here. When we say, let me terminate this one and then go back to our original Java mode. And then if you go to the put method, if you open the put method, you guys see here key value, and it is going to use hash code of key as a key and then value, isn't it? So basically what happens is, here it is receiving the key value pair and is applying hashing of key, right? So internally it is using hash code method. So if you see here, what happens is hash code of key, which is nothing but this one. Whatever we have seen here, hashing of key. Yeah. And if the key value pair, let me open this one. You can see here, you're getting hash key, you're getting key, right? So this is the internal logic, how it is going to get the bucket number. Okay. So this is how it internally uses. So put method internally uses hash method of a particular key, and then it is going to find the right bucket number. Okay. So the bucket number, whatever it is getting, so basically it is going to use that to store the data. If we see here, first it is going to get the hash using hash code method of this key. Okay. Using this hash, it is going to apply some logic here, which is nothing but n-1, which is nothing but 16 is the index, right? Size, right? By default 16 size. So it will apply n-1, which is nothing but 16 minus 1 is 15. So 15 is going to apply it. So by doing this logic, it is going to get the index. So this is the high level way I routed here. But internally how it works is based on this algorithm. Okay, this is how it is going to get the bucket number. Okay, based on this bucket number, it is going to store the data here. Let's say here on the 0th bucket, it is going to store this first one, which is nothing but course ID 0001, because for course ID 0001, the bucket number it is getting it as 0. So it is stored here. First one is key, then hash code, then value, and the next value, because nothing but this is one node and this is another node within linked list, right? So linked list is nothing but lists are linked, arrays are linked, right? As simple as such. Now the second one is another node which will be having key value pair, whatever you have it here. So other one is nothing but null 0001. So null is a key, so it is storing null here, and then hash code of null is 0, so it is 0, and then value is nothing but 0001. So this is 0001, and then this is null, and this stores the value of this particular node, right? So this is how it internally stores the data. So it is using hash code method to get the, it is using hashing on key to get the right index or bucket to store the data. This is what I mentioned here, how it is using hash code method to store the hash objects. And whenever you're trying to retrieve the data, it is going to apply equals method. The way how it equals method applies, whenever you say hm.get of key, you are giving a key and you want to get the value, right? So first it will do on the key, whichever you're passing it, first it will apply the hash code method, and then it will identify the bucket. Okay, let's say you are entering, let's say hm.get of channel name. So your expectation should be, output should be Red9SysTech, isn't it? You are looking for the value for channel name. So how it works is, whenever you say hm.get of key, which is channel name, so it is going to apply the same thing, hash code on the particular key. So hashing on channel name, whatever it is going to apply this logic. Let's say you are getting the output, let's say index as 4. So then it will go and check in the index or the bucket 4. Within this one, it is going to apply key dot equals, because there is a possibility that you can have more than one list stored in the same bucket, isn't it? So that is the reason it is going to apply key dot equals method, which means underneath of this particular index 4, whatever the node which is having the key which is equals with whatever you're passing here, right? Because this is string, this is string. It is using equals method to identify the right node, and that node, whatever the value it contains, that value will be returned back. That is how you are able to store, you will be getting the value as Red9SysTech. Let's say if you are getting hm.put of course ID, so your expectation is nothing but 0001. So how it will be done? First it will use hashing on course ID, then using this algorithm it will get the bucket number as 0. Within that you have two nodes, right? So how it will get this node? It will navigate one by one, it will read by one by one. So first it will apply key equals method on this one. Let's say course ID equals here 0001. Yes, it matches. So it will return the 0001. Okay, this course ID equals this course ID. Yes, because both the content is same. Equals method is returning object same, right? Content same. Then it will take this corresponding value and it will be returned back. Let's assume that you want to go to here and get it, but you have to go one by one because you have to navigate, right? That's a drawback of linked list, right? So this is how it is stored, and it is going to retrieve by using key equals method. Okay, so to store the data, it is using hash code. To retrieve the data, it is using equals method. Very, very important to understand. Now, until Java 1.8, when I say until like 1.7, till 1.7, what they did is they are using Java 1.7 version where it is using linked list to store the data. So, what is the problematic here? Okay, let's say in a particular bucket you have 10 nodes. Okay, and if you want to get the 10th node, then what you have to do? You have to go to the 10th node only by traversing through 1, 2, 3, 4, right? First you have to go and check the first node, then you have to check the second node, then third node. Only finally you will reach 10th node is having equals method true. Then you will be getting it. So here the time complexity is O of n. O of n means something but the order of n is something but 8, right? So 8 times you have to do the same operation, which is O of n. But what they did is, in order to tune this, do a performance improvement in the hash map, what they did, the way how it stores the data, they researched it. So if any bucket it is having 8 nodes, then it will be stored as a list, linked list. The moment it started using 9th node in the same bucket, what they did is, instead of storing it as a linked list, they store it as a tree, binary tree, which is quicker to search and retrieve, right? That is the improvement they did. And why they did? Because of linked list, whenever you want to get the 10th record, you have to go till like one first record, checking with equals method, okay, not matches. Second node, okay, take the key, and then equals method, okay, not matches. Like that you have to do for third record, fourth record, fifth record. So till 9th record, then till 10th record only you will get a match. So in this case, what you did traverse from first record to 10th node, right? So 10 times you have did the same operation. That is why I'm saying O of n, right? Time complexity is O of n. And if you do with the tree map, the time complexity O of log n, okay, which is less than this O of n. So that is how Oracle team made a change in this hash map in Java 1.8. So that in Java 1.8, hash code map internally stores the structure like this. So this is all about how hash map internally works and why they made the changes to improve the performance of hash map. And how it is going to improve is, you have to explain like this, right? If they're not improving by having a double tree, or sorry, balance tree, if they use linked list, then time complexity is O of n. Instead of go for O of n, they have made it to O of log n by implementing with the help of balance tree. So this is how it internally works in Java, the hash map. So anyone have any question? Nitya, do you have any question?
No, Karthik.
Okay, cool. Yeah, that's all for today. Because once you guys understand this one, digest this one, then we can go for hash set and hash table tomorrow, how it internally works. And then next class we will start with comparable and comparator interfaces, so that we will cover up everything in collection framework. The only thing is we have enumeration, iterator, list iterator. Maybe I can make it as an assignment, or I can cover it up in the upcoming classes. We'll see how it goes. So if you're able to understand this hash map now, so tomorrow's class in the hash set, it is very, very easy, because hash set internally uses hash map. Okay, hash set internally uses hash map. We will see tomorrow's class how hash set works internally. But how the hash map works internally is what we have to understand today. I hope you guys have understood here how it internally stores the data, right? Okay, Nitya, if you don't have any question, then probably we can wind up for today, and then we can regroup tomorrow to go for the remaining classes.
Okay, Karthik.
Yeah. Thanks, Nitya. Bye.
Thanks, Karthik. Bye.